Welcome everyone, and thank you for joining the Clean Air Day webinar. I'm Jill Barber, the Outreach and Events Coordinator for CSER. Please note that this conference will be recorded. All attendees will be muted. Please use the Q&A button on the home screen for any questions, and we will try to answer those during the Q&A portion of the webinar. We will be presenting polls at the beginning of each talk. Please be sure to participate in those for a chance to win your own personal air monitor at the end of the webinar. Now, I would like to say a few words about today's wonderful host, CSER Director, Dr. Matt Barth. Dr. Barth's research focuses on a wide range of sustainable transportation topics, including shared mobility, vehicle electrification, and how connected and automated vehicles can improve safety, mobility, and the environment. Professor Barth is active in a number of organizations, including the U.S. Transportation Research Board, currently serving on the Transportation and Air Quality Committee and the Intelligent Transportation Systems Committee. Welcome, Matt.
Great, thank you, Jill, and welcome everybody to the California Clean Air Day. So real quickly about the California Clean Air Day, it was a concept developed originally by the Coalition for Clean Air. So I want to give a shout out to the Coalition. They've done a great job of organizing a number of different events. October 7th is California's Clean Air Day, and a lot of the different organizations affiliated with the Coalition are doing different events in support of clean air. UC Riverside Center for Environmental Research and Technology is also very much involved with this. And so our event, of course, is today's webinar that we hope to be very interactive. We have 4 very interesting talks that we're going to have this morning. And then a little bit later on, we're going to have a panel that really touches on a lot of the different clean air issues that we're dealing with today. You know, obviously it's been a very crazy year, 2020, a lot of different things going on. And of course, wildfires are going crazy. And of course, we're dealing not only with the air pollutants that are associated with the wildfires, but of course, the climate change issues that are associated as well. And you know, in addition to the wildfires, we still have to deal with persistent ozone and particles and other things from our regular sources, mobile sources, as well as stationary. So even though we've made great progress over the years, you know, I think we still have quite a bit of work to do. And I'm very proud of the work that we do here at CSER. We have 4 very young researchers that are going to be speaking today, talking about our different projects. You know, you'll hear all sorts of things in terms of community air monitoring, some traffic studies, and different things like that. Our research is sponsored from a number of different organizations. You know, there's probably too many to mention now, but you know, you'll hear a little bit about it during the presentations. But you know, the California Air Resources Board is involved, South Coast Air Quality Management District, our National Center for Sustainable Transportation, hosted up at UC Davis, the University of California ITS programs. There's a large number of them, including the federal grants as well from the National Science Foundation. So like I said, we're real excited to get going. We have poll questions that we're going to be doing. And so remember, please participate in the polls, because we're then using your inputs as part of a raffle prize. So the raffle prize is going to be an air quality monitor, and Nicole, our deputy director, is going to tell you a little bit more about that later on in today's presentation. So Jill, why don't we go ahead and pull up the first poll for Fortino before I introduce him. Okay, so hopefully everyone can see this. And, you know, I think we've heard from many different institutions and organizations across the state about, you know, becoming about becoming carbon neutral. And it turns out the University of California was one of the first to declare officially that we'll go to carbon neutrality. Back roughly 7 years ago is when that was declared. But what I've seen with many organizations is that some are choosing different dates, and you can see the range: 2025, 2035, 2040, 2045, and 2050. So the question is, for the University of California, what have we committed to in terms of becoming carbon neutral? What's the date there? So we'll give a few more seconds, or it looks like we just closed it. Jill?
Yes.
Okay, all right. Well, the majority won. So the 52% that said 2025 is correct. It's a very ambitious goal. When that goal was made 7 years ago, it didn't seem so daunting, but you know, I must say that the University of California has made a lot of great progress in terms of its electricity, renewable electricity, and other things, but it's still quite a challenge to get to that full carbon neutrality. And with that said, I'd like to now introduce our first speaker. Fortino Morales is the University of California Riverside Sustainability Officer. I work closely with Fortino on a number of different sustainability projects across campus. We work together as a team on these different things, focusing both on the academic side as well as operations of the campus. Fortino is one of our homegrown people that have come up through doing a bachelor's degree at UCR and then moving on to his master's degree. He knows UCR very, very well. He's always been dedicated to many different sustainability practices, and he was an obvious choice when we selected him for our sustainability officer. So with that, I'd like to have Fortino just take it from here. Go ahead, Fortino.
All right, thank you. And good morning, everyone. And thank you for the invitation to speak and share a little bit about what UC Riverside is doing in relation to climate change and specifically clean air. I'm gonna try to share my PowerPoint and see if that works. All right. So I actually wanted to first start with the land acknowledgement that UC Riverside worked with the native folks in the area in recognition of the lands that we're on now. So just to kind of read the quick statement here that we at UCR would like to respectfully acknowledge and recognize our responsibility to the original and current caretakers of this land, water, and air, the Cahuilla, Tongva, Luiseño, and Serrano peoples, and all of their ancestors and descendants, past, present, and future. Today, this meeting place is home to many indigenous peoples from all over the world, including UCR faculty, students, and staff. And we are grateful to have the opportunity to live and work on these lands. And if you want more information on the Native tribes in your area, there's a website down there that you can kind of link on. And I think it's important to kind of acknowledge this, and especially in the context of the topic today around clean air in this area. And so to kind of talk a little bit about also what the system is working on, and Matt touched on this, in 2013, President Janet Napolitano launched the Carbon Neutrality Initiative with the ambitious goal of having zero emissions from buildings and vehicle fleets by 2025. And so they've launched this initiative, and as part of that, they created 33 fellowships across the entire UC system on an annual basis, and it gives opportunity to students to work on addressing carbon neutrality on their own campuses. I mean, we've seen a wide variety of projects, anything from natural gas work to education and outreach and behavior change, on our campus and across the system. And I think it's a really great way to get students involved in this whole process. In addition to that, the Global Climate Leadership Council was formed, and that is a council of 24 different representatives from across the system. And so this is anything from campus senior leadership to faculty experts in the area, and they really help drive and push forward the carbon neutrality initiative as a whole and kind of oversee the project. So kind of coming a little bit more local to what we're doing here at UC Riverside, I wanted to share kind of the core tenets of what our office works from, and this was developed by the Ad Hoc Faculty Senate Committee on Sustainability in 2017. And this came out of kind of a hiatus of the office, and this ad hoc committee came together to really vision what the new office would look like and the way that we wanted to move forward. And so just to kind of highlight some of the core tenets that they had there, we're looking at the economic decisions aimed at secure livelihood, social justice, and a better world for all generations. And obviously being an academic institution, really wanting to look at the academic and policy investments that we do as a campus, and ensuring that they're supporting the economy, social well-being, and the environment, as well as looking at the attentions to what's happened in the past, constraints of the present, and as well as the future. And then, of course, lastly, and I think this is really kind of prescient for the topic today, is in terms of environmental justice. So encompassing a commitment to confront environmental racism, promote equity, and advance transparency within all the work that we do here. So I think it's just important to kind of to say that these are kind of what our office is kind of operating from in terms of core tenets. And then kind of more on the ground side too, we're driven by a policy that's been established for the entire UC system, policy on sustainable practices. And so I think it is important here too also to mention that this was advocated by students. And so in 2003, actually, a group of students from across the system advocated for the UC Regents to adopt this type of policy. And they started with the first two, so green building design and clean energy. And since then, you can see it's kind of grown to 9 different policy areas. And I'll mention too that they're working on environmental justice and trying to incorporate policy language around that. And so that's kind of a current effort underway right now. And so hopefully in the next year or two, we'll be able to kind of incorporate that as well. So I won't go through all of these different 9 policy areas, but we do have kind of goals for each one of these. But I'll just touch on the ones that I think are relevant for clean air today. So this is a chart actually showing our total campus greenhouse gas emissions over the last 9 years. And just to kind of share with everyone, scope 1 is the green bar at the bottom. And so that's our on-campus generation. And for us, that really means our central plant. So we have, you can imagine we have 4 massive boilers and then an underground tunnel system of about 6 miles that feeds hot water and steam and chilled water to the different buildings on campus. And that's the main driver as it uses natural gas for our on-site carbon emissions. Scope 2, which is the blue bar, is our purchased utilities. And so that's really driven by our purchased electricity. So what we're purchasing from Riverside Public Utilities, and their energy mix is really kind of what drives this, along with our work to reduce the amount of energy that we're using on campus. And so we're really glad to hear that they're going to be leaving the Intermountain Power Plant, the coal-fired power plant in Utah in 2027. And so that's going to actually half that blue bar right there, just that decision alone, as it represents 26% of their energy profile. And then lastly is the yellow bar at the very top, and that's scope 3 emissions. And so that's our commute and our flight emissions. So this is, anyone that's kind of all the students that are coming in classes, the faculty that are coming to campus to do research, and the staff that are helping run the entire university. And then there's also the flights for all the conferences and different events like that too. So. And then just to kind of highlight some of the initiatives that we've been working on around greenhouse gas emissions overall. Matt mentioned that we've been working in the last couple of years to really put more solar generation on campus. And so currently we have about 8 megawatts of solar installed, and that represents about 9% of our total campus energy. We're also currently underway of putting rooftop solar. It's going to be our first installation of rooftop solar, and that's set for early 2021, which we're pretty excited about. We've also been working on energy efficiency programs. So we've been converting a lot of our buildings over to LED lighting and retrofitting those buildings. So we'll continue to do that. And then we're also looking, like I was mentioning, at the central plant efficiency upgrades, and those are kind of underway. So anything from installation to upgrading the control systems are things that we're looking at implementing. And then lastly, we're also working on the commute emissions. So there was a pretty significant reduction over the last 3 years. And I'll share a little bit more about that on the next slide here. So if you remember the slide that I had before, the top bar was the scope 3 emissions. And so this is just a kind of more detailed version of that, what makes up that yellow bar there. And so we see that our commute emissions is kind of the main driver here for our scope 3 emissions. And so again, like I was mentioning, that's everyone kind of driving to campus. We have about, in total, students, staff, and faculty, about 30,000 people that interact with the campus. And that's not including visitors. So it's quite a few miles being driven and commuted to campus. And so we've been really working on trying to reduce that. You can see kind of a pretty significant drop off at the end there. That's only because 17 and 18, we don't have the good numbers on that, kind of due to the campus hiatus on the office there. But what you will see is that there is a pretty big drop off, and I think there's a lot of work that's been done there, and I can share that in the next slide here. So we've developed the UPass program in partnership with the RTA, and that's a program where students, staff, and faculty are able to ride free. And so just this last year, this is of course pre-COVID times. This last year we had 626,000 individual boardings, which represents an 18% increase from the year before. We've also we've had a van pool program going for a couple years now, but it's now at 28 total active van pools. And again, that was pre-COVID. I think we're down to 0 currently. Freshman exemption. This is also another policy that's relatively new. When I was a student, this wasn't true. But now freshmen are no longer allowed to bring their car to campus, except for and some exemptions that they can apply for. And then we've also been installing electric vehicle chargers around campus. So currently we have about 32 on campus. And then this is just a quick little picture of a bicycle count that we did this last fall, which was really, I think that was one of the first times that we did a total bike count of all the bike racks on campus and the bikes that were parked there, and trying to get a sense of how many bicyclists are on campus at any given time. And then I'll just mention here too that we have been collaborating, of course, and I think Matt mentioned this at the beginning, with a lot of different entities in the area. So of course, a pretty close relationship with the City of Riverside and RPU. We're also founding members of the Inland Southern California Climate Collaborative, which is a regional group that's looking at the effects of climate change and how to kind of mitigate that. And then also, of course, California Resources Board is coming to the region, which is pretty exciting. And the longstanding partnership with the South Coast Air Quality Management District as well. So with that, just to say that we continue to commit to take actions to reduce our impact on the climate and especially the air quality of the region. So I think I can take some comments and questions now.
Yeah, so Fortino, thank you. And there were a couple questions that came in on the Q&A line, and I'll just read those to you, and you can just answer. So on your energy slide, your base green, which was showing the on-campus energy use, it was flat or maybe even increasing. So the first question is why is it increasing? I mean, I know the answer, but why don't you tell the audience?
So I think the main driver there is just actually like weather. So normalizing for weather is one of the big reasons there, and so. Yeah, that's one of the main drivers for that fluctuation on a yearly basis.
Well, I mean, I would also say enrollment, right? I mean, our enrollment continues to grow as part of our growth plan. So the more bodies you have on campus, the more buildings and everything else, and therefore energy has to go up just because of that.
Yeah, and the thing I'll add to that too is that that has been true, and I think there's a new policy within the sustainability system-wide policy that says that no new buildings can have a natural gas infrastructure in them. So you'll see that scope 1 really drop off. The other thing I didn't really mention there is that kind of like Matt was saying, is the student population, the campus population over the last 9 years has actually increased significantly and at a higher rate than the energy use. So we've actually been holding pretty steady and in consideration to the amount of people that are coming to campus. Yeah.
Okay. All right. So Fortino, one last question is about air travel. So does UCR have any active programs in offsetting the emissions from our air travel?
Not currently. That's something that we're looking at for the 2025 year. And so we will need to purchase some carbon offsets to get to that last carbon neutrality. And so we actually have a system-wide working group that's looking at carbon offsets, kind of vetting them, because there's kind of a wide variety of quality that you can look at when you're purchasing carbon offsets. And so it's not something that we currently do, but we will be doing that in the near future. Yeah.
Great. All right. Well, thank you, Fortino. Obviously, a lot of good work has been done, but there's quite a bit of work to be done in the future. So we're glad that you're extremely active in that field. Okay, let's go on now to our next presentation. So let's see here. So this, we're going to talk about community air monitoring. And so the question that we have in front of us is, what is the Inland Empire's community that is being evaluated as part of the AB 6170 Community Clean Air Phase 1 program? So as you know, there's a number of different communities throughout the state that are in this Phase 1 study of monitoring. There's just one in the Inland Empire. And so it's, there's the answers. Okay, the polling is closed. And again, it looks like the majority of people got the correct answer, 59% San Bernardino Muscoy, which is correct. And so some of those others are also dealing with community air monitoring, but the AB 617 community is the San Bernardino Muscoy area. And so touch on that topic is our next speaker, Dr. Sunni Ivey. Dr. Ivey is another one of our newer assistant professors that's part of the Chemical Environmental Engineering Department. She interacts quite a bit with us at CSERT. That's where her laboratories are. But she's also very active with other parts of campus. She's part of the School of Medicine's Breathe Center. She deals with the School of Public Policy. She interacts quite a bit with our CNAS environmental toxicology program. So she's very, very active, and she's very collaborative in terms of working with a number of different groups. She got her PhD from Georgia Tech, and we're very happy to have her. And so, Sunni, tell us all about clean air monitoring.
Okay, good morning. Just confirming that you can see the presentation. Okay. So good morning, everyone. Again, I'm Dr. Sunni Ivey, and I'm going to talk about my group's recent effort to incorporate wearable air pollution sensors to assess environmental justice and PM 2.5 exposure disparities. I'd like to start by thanking the sponsors and the wonderful contributors to this work, my colleagues at UC Riverside, or rather my student, Kondo, my third-year graduate student, our environmental sociologist, Marilyn Grail-Brisk, and my undergraduate student from Inland Empire, Jasmine Velasquez, Heather Smith from RCC, my external collaborator, Halfei Yu, and of course, CCAEJ members, or formerly at CCAEJ, Chela Larios, Jean Cayano, Andrea Vidare, and Anthony Victoria, and also our undergraduate assistants that were incoming transfer students from RCC, Hector, Priscilla, David, Sarai, and Aaron. And without this group of people, this work could not have been done. And herein lies the strength in community-oriented research. I'll first start off by introducing my lab. Some of you are familiar with my lab, but if not, I am the PI of the Air Quality Modeling and Exposure Lab, and our research mission is to develop and apply advanced air quality modeling and data fusion approaches to characterize air pollution in the United States. And of course, these approaches are useful for understanding community scale exposure and source characterization. So everything that I do falls under the umbrella of this research mission. The next thing I'm going to do is highlight the strength of air quality research at UCR. We have researchers that work on molecular scale, nanoscale, up all the way into the regional and global scales in terms of air quality. And we've also recently signed a memorandum of understanding with the California Air Resources Board to engage with our students in training in the area of air quality technology and science. And if you have your phone available, feel free to scan this QR code to learn more about that MOU. There will be other QR codes placed throughout the presentation to engage with the content. And of course, I'd like to highlight our CSERT air quality researchers in the Emissions and Fuels Research Group, as well as our Atmospheric Processes Group. So what's the motivation for my work? Well, most recently in the news, we've heard about the pretty extreme air pollution measurements for ozone that we've seen here at the end of the summer. So much so that it has caught the attention of the LA Times quite a few times this past month. On the left, this is the story of the LA Monitor hitting above 180 ppb for hourly 1 hour ozone, which is the highest level seen since the late 1990s, the mid to late 1990s. And the second story highlights the high ozone that was seen as a result of the confluence of a major wildfire and its smoke in the basin, an extreme heat event, as well as really high ozone levels. So this motivates why much of the research at CSERT is being conducted, and that's to improve the air quality in the South Coast Air Basin. Other motivations, local motivations for the work that I'm conducting in my lab is the implications and the results that came out of the multiple air toxics exposure study, specifically study 4, that enumerated the cancer risk in the South Coast Air Basin. The figure on the left is showing the change in risk from 2005 to 2012, and the plot on the right is showing the cancer risk per million for the updated MATE study. And the interesting thing about this cancer risk is that it's largely driven by the on-road and off-road vehicle networks. Particularly the pollutants of interest for this cancer risk are diesel PM. So what I'm attempting to do in my work is to hone in on what's going on in the Inland Empire, and that's what's highlighted in the blue circle. It goes a little bit beyond that, but my research area tends to center around that blue circle. And while I will not be making direct measurements of cancer risk, I make measurements of proxies for adverse exposure to pollutants. And I'll explain what that means in just a second. So now that we've set up the motivation for the work and why air pollution is so important in the South Coast Air Basin, I'd like to talk about the aspect of exposure studies that is sometimes omitted. So human mobility has been shown to greatly affect how we characterize personal exposure. So I'm highlighting 2 preceding papers from my colleague and collaborator, Professor Haofei Yu. In his first study, which we worked together on, he's looking at the efficacy of using Google Maps location history to track one's mobility. And what he's showing is that in a comparison to a GPS data logger, his Google Maps location history actually does a great job at tracking that. And so I'll say that cellular data is actually an effective way to track human mobility. And I put effective in stars because there is, unfortunately, a privacy issue with using cellular data. In this second study, we've highlighted here the difference between the home-based exposure, or when you assume that a person is stationary all day, versus their call detail record exposure, that's the CDRE. And the call detail record exposure is based on where their cell phone pings throughout the day. And so there's a bit of a change of support issue with the distance from the tower to the person. And this study was conducted for 1 day in Shenzhen, China. And these data are actually publicly available for public consumption, and they've been anonymized and scrambled for privacy. And what happens here is I'm showing the group 2 mobility versus the group 10 mobility. And group 2 are people that actually visited 2 grid cells in 1 day. Group 10 participants visited 10 grid cells per day. And what we can see is that participants with higher mobility are most likely to have their personal exposure misclassified, as you can see by the bars on the left being matched to different quartiles on the right. And so this is what really sets up the core mission for personal exposure measurements in my study area. And so going back to the poll question, my research centers around the AB617 community of San Bernardino Muscoid, which is a phase 1 community. And I'm showing you here a screenshot of the wonderful website that has been put together by the South Coast Air Quality Management District, where you can actually go and engage with the continuous measurements being made in these communities. And also, there's a map here in the bottom right showing how interactive AQMD has been with the communities to identify the locations of concern, whether these are truck idling locations or point sources that they deem to be problematic for their communities. This actually sets up a very nice public interface for people to engage with the data. So with that being said, I'm going to talk about our actual pilot personal exposure study. And feel free to engage with the QR code to see our preprint. But just as a caveat, this paper is currently under revision, and the results I'm showing you here are the updates as a result of that peer review. So what we've done is we've collected consecutive 24-hour measurements for 18 individuals over the spring of 2019. We had 18 adults, and we had actually 1 invalid participant data set. So I'll be showing you the results from 17 adults from 5 different cities: Moreno Valley, Redlands, Riverside, San Bernardino, and Yucaipa. And we've actually tracked their measurements with GPS data logger, and that resolution is 5 seconds. And we've actually tracked their PM2.5 exposure with these applied particle technology wearable monitors. And those measurements are made every 15 seconds. And so of course we follow IRB protocol, and the results that I'm going to show you have been aggregated and anonymized for privacy. So on the scientific side, we have to actually co-locate and adjust these measurements because low-cost sensors have been shown to have dependence on temperature and relative humidity. And so we've done a short co-location here, courtesy of the South Coast Air Quality Management District. They allowed us to co-locate at their Mira Loma Van Buren monitoring site. And so we are actually comparing our personal measurements with a MET1 BAM. And this is just showing the flow of information for checking for relative humidity and temperature dependence. And we first applied a polynomial correction, but we later switched over to the linear fit, given the uncertainty of the high personal measurements that we actually measured during our study. And so what I'm showing you here is an example of checking for relative humidity dependence. And as you can see, if this coefficient of determination is less than 0.4, then we can rule out relative humidity dependence. And talk a little bit more about this relative humidity dependence. This recent study on the left has shown that between about 20 and 60% relative humidity, we're within 20% of the reference monitor. And so I'm just demonstrating that here. And on the right, we see that there begins to be a divergence in our corrections with the linear fit versus the polynomial fit. So we do believe the linear fit is better for our high concentrations. This is just reiterating again that our actual field measurements of relative humidity for every participant, all 17 participants, range between about 10 to 50% relative humidity. So we think that our correlation with the reference monitor should be pretty good. So the next cool thing we've done is that we've actually classified over 900,000 data points spatially using this density-based spatial clustering of applications with noise. And so what this allows us to do is to take these spatial temporal data and cluster them into microenvironments. And so we classify these microenvironments based on the Google Maps label or whether or not this is the participant's home or their work. And so we're privy to that information beforehand. And here are the exciting results. And so we've been able to classify 5-second personal exposure data in 7 different microenvironments, including work, from left to right, home, work, our restaurant, retail, leisure indoor, leisure outdoor, transient, which is designated by the speed. So if you're greater than, I believe our threshold was 10 kilometers per hour, then you're classified as being transient. Anything less than that goes into a cluster. And then we have our unclassified measurements, which for the most part were not a great percentage of the data. And the main take-home message is that for our San Bernardino participants, the distribution of their personal measurements at home were higher, were much higher than, say, our Riverside and Redlands participants. And these aggregations are only valid for people with greater than 50% data recovery. So we are making sure that we're doing this initial aggregation for valid data sets. And as you can see, San Bernardino has the highest poverty rate, while Riverside and Redlands have the second and third lowest, but the highest median household income. So despite the high level of mobility of the participants, their home microenvironments are still quite high risk for exposure. So in summary, I'd like to say that most of the time was spent in the home, but there is a greater percentage of the time spent outside of the home. And so these may be important for voluntary or involuntary personal exposures. So, yeah. And so looking forward, in regard to exposure mitigation, we have to take into account these personal measurements as well as ambient reductions concurrently. And so in the future, we're going to relate these exposures to visitation of high-risk non-residential points of interest. And with that, if you're interested in learning more about my group, feel free to contact me at any of these links here. Thank you.
Great. Thank you, Sunny, very much. Very interesting work. Quite a lot to absorb there.
I know.
and I like your QR codes. I checked them with my iPhone and they work great. So, hey, a couple quick questions before we move on to the next presentation. I guess one general one that I've heard from the audience is, you know, we have these personal monitors now, but you talked a lot about the various sources of uncertainty and error and all that. So how did, I mean, if I was a resident and I wanted to get one of these, how much do I believe actually what readings they're telling me? I mean, do I have to think about these kind of corrections, or what would you say on that?
So if the relative exposure. So if you're in a clean indoor environment versus a smoky indoor environment, the monitor measurement accuracy becomes more important. We're just trying to provide relative proxy measurements to have an estimate of the exposure risk relative to where people move throughout their day.
Okay.
Should I answer the questions in the Q&A chat?
Yeah, so I think because of time,
All right.
why don't we just do one more answer live one, and then you can type in the other one. So why don't we just take that one from Michelle Burroughs? What can be done to reduce the risk of home exposure?
In the home, you can actually set up standalone filtration units. So I purchased one of these from the store. More involved interventions would be to retrofit your home for better filtration and higher ventilation rates. Thank you,
Okay.
Matt.
Sounds great. All right. Thank you very much, Sunny. Great talk. And if you don't mind answering those questions just by typing the answer, that would be great. And the audience can see those. Okay, we're going to move on to the next talk. And so we're going to talk about some mitigation techniques, particularly as they're focused around transportation. And to lead into the talk, we have this next poll question. So what can be done to minimize transportation impacts of goods movement in the Inland Empire? And we have all sorts of interesting answers there. Heavy duty truck electrification, optimized routing, vehicle connectivity and automation, better land use. So lots of good choices there. All right, looks like the poll is closed and 96% of you listed all of the above, and that's correct. I mean, these are all very important things that we need to do in order to, as we said, minimize the impacts of goods movement. I mean, goods movement's not going away, right? So particularly in the age of COVID, you know, we're ordering things online, they're being delivered to our homes, and goods movement, the miles associated with goods movement is easily outpacing the miles of people normally driving. So it's a big concern, especially with all the warehousing here in the Inland Empire. So our next speaker is, again, one of our research faculty at CSERT. Jill Liu was a student here at UCR. She got her PhD in environmental engineering. And so basically it works on a number of things focused on vehicle routing. And that's going to be the main topic of her talk. So Jill, go ahead and get started, please.
Hi, everyone. Thank you, Matt, for the introduction. Good morning, everyone. I'm another Jill Law, the Assistant Project Engineer at CSERT. Today, my talk is about reducing the impacts of goods movement in the Inland Empire. I would like to start with my thanks to our colleagues in this project and the Clean Air Day webinar for their great efforts to make it happen. Okay, this project is a part of the Climate Smart Transportation and the Communities Consortium, sponsored by the State Strategic Growth Council, whose goals are using a combination of investment and programs to make our communities healthy and resilient towards climate change. One of the big topic is about improving the various mobility options and make those options more sustainable, which is the theme of this project. Okay, many of you are probably aware of that there is an explosive growth of warehousing industry in the Inland Empire, with little consideration on the transportation capacity nor the local communities. How do these warehouses and associated truck traffic affect residential neighborhoods? There are many concerns that increased truck volume will affect roadway safety, will bring more congestion and will potentially downgrade local air quality. In attempt to address those issues, we have several solutions from different perspectives. For example, we have the heavy-duty electrification tools. Which will have zero tailpipe emissions on the road. We have the connectivity and the partial automation option that can assist the drivers to drive safer and more efficiently. Therefore, less emissions and pollutants will be emitted. On top of that, we also have the fleet management tools that can further reduce the emissions in impacts and improve efficiency by using routing, dynamic time of day scheduling, and geofencing strategies. A part of the project is to look into the low exposure truck routing. As part of our Volvo project, CISR is also developing the novel algorithms for dispatching electric trucks to improve the overall system efficiency. And the next, I would like to refresh some memories about vehicle routing. Usually, most trucks use navigation based on the fastest route. The eco routes can reduce fuel consumption with a small travel penalty. For example, in the lower right figure, if one drives from the North LA to the North Orange County, there could be several combinations of different freeways. When considering traffic speed, the truck load, and the road grade, there will be a route that uses less fuel, but with a slight fuel penalty compared with the fastest route. Similarly, low exposure routes can reduce exposure pollutants to the local residents, also with a slight travel time penalty. No exposure routes is calculated by factoring how much truck emitted pollutants is brought into the neighborhoods and how many sensitive populations are near the road. Okay, for example, this is the study area of the San Bernardino Airport and its surroundings. The red star marks a proposed location to be expanded to a major Amazon air cargo hub in the near future. We can see that the residents live around the area, and we can imagine that if the air hub were to be built in the future, there will be more trucks coming in and out of the area. And how will the truck emitted pollutants disperse into the neighborhoods? How many residents are in the houses? How many schools are nearby? How much pollutants will be inhaled by the localized people? Will there be an alternative route instead of a fastest route that can reduce the overall pollutants to be inhaled by the localized population? We attempt to address those questions. Okay, now this is a busy slide. And let me help you understand what those circles, the lines, and the color mean. So circles represent places where the susceptible population are at. For example, daycare centers, elementary, middle, high schools, and assisted living facilities. The bigger the circles means more people are at that location at 10 a.m. of a typical weekday. The gray shaded blocks in the background shows the residents staying house during a typical weekday, which is pre-COVID estimation. The arrows at the corner shows the wind direction at 10 a.m. during our simulation, which is also a common wind direction in the general inland area. And the colored line showed the roadway network. We can see that the freeway 10, 210, 215, and the highways into the mountains, and the various local streets. The color shows that when the truck passes by the link of road, how many micrograms of PM2.5 emitted from the truck's tailpipe will be inhaled by the people in the places and in their houses near the road. For example, at the top left corner, there is an elementary school, a middle school, and a dense residential housing, which means that when the truck passes the road here, more pollutants will be inhaled by the people around the road here. And in contrast, when the truck passes the green links down here, there will be less impacts to the surrounding neighborhoods. We calculate, factor in a combination of location of the population to the road, micrometeorology, and the age-specific breathing rate weighted by average human weight. Therefore, when a truck drives down the 215, the red sections will have more impacts to the neighborhood, and the green sections will have relatively less impacts based on a number of our assumptions. Okay, here is an example. If a model year 2012 truck starts from the junction of I-215 South and the 210 and heads towards the San Bernardino Airport, the coral route shows a fastest route, which is mostly on freeways, and the green line marks the low exposure route, potentially, which cuts into a local connector streets towards the warehouse. When we compare the two routes, we found that the LER can achieve better fuel consumption, less CO2 emissions, and PM 2.5 inhalation with a slight travel time penalty. We can analyze such routes comparison for each of the corner of area with such trade-offs. At the same time, we utilized California freeway performance measurement systems to estimate the truck volume loading into the hub from each corner of the area. For example, we found that the volume of the trucks exiting the I-10 and Mountain View Avenue looks like a curve like this. A first peak starts around 7 a.m. and a large peak at 3 p.m. Therefore, with all this information, we will be able to weight each corner's incoming truck volume and the various driving metrics. For example, distance, time, PM 2.5. And the general conclusion is that we can achieve a 28% reduction in pollutant exposure and reduce fuel consumption by around 5%, but with an increased travel time by 13%. This is work in progress. We're working on the low exposure route selection so that the time penalty can be largely reduced. And we are also aware of that we should refine the analysis with considering the traffic signals on the local roads. Previous analysis assumed roughly constant speeds with no stopping. This analysis, we examine the effect of its stopping at each stoplight and the pollutants they emit. We found that there are more than 12 stoplights around the 3-mile stretch of the green route. With truck simulation data, we found that averagely a truck stops around at least once every 5 intersections. About 40 seconds will be lost at each stop. Therefore, we found that stoplights will make our previous low exposure routes less effective. However, to address these issues, traffic signals synchronized with vehicle traffic can improve the performance. We have several technologies we can apply to address this issue. One is the eco approach and departure. The other is free signal priority. For the eco approach and departure, the application utilizes the traffic signal phase and timing data to provide driver recommendations to encourage a more fuel efficient approach to signalize intersections. And the overall energy savings between 10 to 20% depending on the traffic condition, the traffic volume, and the truck ratio. Okay, in March 2019, CSERT demonstrated the truck eco-routing in Carson, California, with the participation of many stakeholders. And I would like to show everyone the demo video. Okay, so this is the EcoDrive advisory system. The lights here indicates what's the current phase of the stoplight ahead of it. So there is a stoplight about 500 meters ahead of the camera right now. And the little green bar on the meter shows the recommended speed range. This is an accelerated scenario. When the eco-drive advises to speed up to pass the green light, as we can see later. So the current phase is green. And it turned yellow right when the truck passes the intersection. We can see that without the speed advisory, if it drives a little bit slower, the driver will have to come to a full stop at the intersection. And the next is a deceleration scenario. So the traffic light ahead right now is green. And in a few seconds, it's going to turn red. Okay, now the system advises to slow down. So that when the truck passes the intersection, it will turn green, so to avoid a full stop at an intersection. The energy saving, again, is between 10 to 20%, depending on the traffic conditions, such as the traffic volume and the truck ratio. When the technology becomes widely accessible for the freight industry, there will be a significant reduction in terms of both CO2 and the pollutants, as we can foresee. Okay, let me go to the next slide. Talks about the potential adoption of formal policies at the regulatory levels. We think local and regional transportation departments and agencies can use their authorities to limit the use of certain routes by heavy-duty trucks or designate low-exposure truck routes. And air quality regulators could adopt indirect source rules that mandate or incentivize alternative routing or geofencing strategies. For example, South Coast AQMD has the proposed Rule 2305, which is the warehouse indirect source rule. And we also have the potential voluntary actions by the industry leaders. We think that new industry level norms could be the industry leaders adopt low impact emissions routing guidelines, and they could take the first step to adopt those new standards in the Inland Empire to lower the impacts of goods movement in the Inland Empire. Yeah, that's my presentation today. Thank you. And I'd like to answer any questions.
Great, thank you very much, Jill. Very interesting work. We have a few questions that came up. So why don't we ask the first question, which is, are you working with any of the logistics company on rerouting? And then are there any companies that are willing to implement this type of system?
Okay, currently we, okay, then I'll hand it to Matt.
Okay, yeah, no, I can help with this. So the answer is yes. So we actually have a meeting in the next 2 weeks with Amazon. So we're actually going to propose some of these different techniques to Amazon and see what they potentially want to do with this. But keep in mind too that there's already several pilots ongoing throughout the South Coast Air Basin that are working on several of these truck strategies. You know, Jill showed the eco approach and departure at the signals. There's freight signal priority. So that I would say there's pockets of several companies that are trying this as part of the pilot programs. And when we can actually measure real world improvements, then I think we'll have a lot better basis to going to companies and seeing if they can actually implement that. So we're pretty early on in the stages, but I think there's interest from various drayage companies and others throughout the South Coast Air Basin. Okay, so the other question, Jill, very quickly is, you know, for the air quality issues, we're focused on the tailpipe. But what about other non-tailpipe emissions, such as tire wear, road dust, brake wear, and all that? Is that come into play in terms of your analysis?
Right. I understand that makes up a big, a large portion of the on-road emission as well. That's why we started factor in the microscopic truck trajectories to include the acceleration, deceleration events, so that we can potentially incorporate the road dust and the tire wear, brake wear into this analysis. Thank you.
Great. Okay. All right, Jill, again, thank you very much. It was a great talk. And I don't know if you want to also go to the Q&A page and type in the answers for the questions that we didn't get to.
Sure.
We're going to move on to the fourth presentation. And then after this, of course, we'll have a short break and then move on to the panel. But the next topic deals with COVID and how COVID has affected our lives, and particularly focused on transportation. So if we can, yeah, the next poll question is there. So since COVID-19 hit, how many fewer miles are you personally driving per day? So this isn't a correct answer. We're just interested in polling the audience to see how much they've actually reduced their driving. And this is really one of the things that we're trying to understand a lot better across all of Southern California. So 74 answers. So it looks like most people are saying, 60% of the audience are saying that they've had greater than a 50% reduction. So that's pretty significant. A few people, which I'm interested in, 7% of the audience said they're potentially driving the same number of miles or maybe even driving a little bit more. So this is the exact topic of what we're focusing on in this next study. And so we're very privileged to have Dr. Shams Tanvir join us. So Shams came to CSERT a number of years ago as a postdoctoral researcher, became research faculty at CSERT. His background is in transportation engineering, and of course it's tied in with a lot of environmental issues too. Shams just recently got a new position. He's now an assistant professor at Cal Poly San Luis Obispo. He's been very busy lately teaching his classes. So we're very fortunate and very happy that Shams could join us this morning. So Shams is going to talk about the transportation effect of the COVID experience. So Shams, take it away.
Thanks, Matt, for the introduction. And pardon me if my lawnmower just started buzzing around out of the window, and that happens with COVID. So the topic that I'm going to present today, it's on how COVID-19 has impacted transportation in Southern California. So I'm Shams Tanvir. I am an assistant professor in California Polytechnic State University at San Luis Obispo, and I've been fortunate to work with my colleagues at UCR, and basically the motivation for the whole work, as you can see on the right side, this is a report taken from Southern California Association of Government. They had done a study on how the vehicle miles traveled at different counties within the Southern California region has changed over the time on the COVID pandemic. And you can see the top 3 lines in here. Those are represented by the Imperial counties, Orange County, San Bernardino County, and Riverside counties. Those are the places where, although all across the board in Southern California, traffic levels reduced by more than 60% to 80% in some places, but those 3 counties did not experience as much traffic reduction as the other places. And you can see that although we can see regional differences at the county level, we can also see the recovery of the traffic level reduction due to COVID has not been uniform. So some places, specifically more inland places that did not have access to jobs that would allow them to do remote work or telecommuting, those places did not have enough or a significant reduction compared to some places near the coast. And we can see the level of fluctuation in terms of the level of traffic drop and the recovery process would cause a lot of issues regarding their environmental justice, because all these people, they are from the different socio-demographic characteristics, and their the differences in the exposure level because of the changes in traffic level are different for those people. So the project goal is we want to understand and quantify the traffic changes due to the traffic shutdown that happened during the COVID-19 pandemic. And then we want to quantify and relate the changes in air quality to the spatial and temporal shifts in traffic. And finally, we draw a conclusion about the changes in the air pollutant exposure risk for vulnerable population. So to achieve these objectives, we've taken data from 3 different types. So first type of data we have taken is for the traffic flow. So we got the traffic data from Caltrans Performance Measurement System, the PEMS site. They have traffic sensors that measures speed, density, and traffic volume on the freeway network in all over California. And specifically in this case, we looked into the stations that are in Southern California. And to focus our analysis, we focused on only the weekdays, excluding Mondays and Fridays, and between the times 3 p.m. to 7 p.m. And the analysis was conducted all through the COVID time, so from beginning of January to the current time. For air quality data, we took the data from the AQMIS system managed by CARB, and we took mainly the hourly carbon monoxide and NOx concentration and see the temporal and spatial variance across the different parts in Southern California. For environmental justice, we looked into the 2018 Cal Enviro screen data managed by the Office of Environmental Health Hazard Assessment. And basically, they developed a score to represent the population environmental justice level based on their burden to exposure to different pollutants and also different socioeconomic characteristics. And this score, they call the CES score. It varies by the different census tract. So as you can see that our data from traffic to air quality to environmental justice, those varies spatially and temporally in terms of both reported interval and also in terms of their resolution. So here, we basically, in the beginning of the project, we looked into how traffic levels changed in the first week of the shutdown. And we're trying to relate the traffic level changes with the different air quality and the environmental justice parameters. So on the left here, you can see this is a census tract level map for a particular week in March. So this was the first week of shutdown. And the different colors represent how much traffic increased and decreased compared to a baseline traffic level. So in this case, we took the average of January and February traffic level for the different areas as kind of the baseline and compared the weekly traffic flow data with that baseline. So when we have a color like yellow and orange, those are increased compared to baseline. And in March, you can see those are pretty rare. But then the pink shade, it's a slight decrease, so less than 25 decrease. The purple shades are where a moderate amount of traffic decrease had happened. So those are in between 25 to 50% decrease. And the blue shades are where more than 50% traffic level decrease had happened. And on the right, you can see this is Caltrans District 7 reported vehicle miles traveled across the different weeks in the year. So you can see that the blue line that represents the total traffic vehicle miles traveled, that was pretty stable till the beginning of March. And sometimes around March, that whole, because of COVID panic, even before the shutdown, the whole traffic level was going down. And you can see the truck VMT was a little bit slow to react, but it was also going down accordingly. But then sometimes after April 5, traffic level slowly were coming back up. But if you can see, like even sometimes around June, the traffic level came back up, but it did not came back up to the level of the pre-COVID situation. So in the next few slides, I'm going to show kind of a temporal progression of the traffic flow change across the different areas in Southern California. So in this first video, you can see the different weeks in our analysis period. And sometimes around March, we can see the whole map kind of turning purple. So traffic flow levels are reducing. And we can see some, I want to pause sometimes in April because that was kind of the height of the traffic flow reduction. And you can see several pockets of blue in the maps coming up. So on the bottom of the map, near the coastal Orange County, we see a significant decrease in traffic level. Similarly, we see a significant decrease of traffic level on the up north, near the northern Los Angeles County region. But we do also see that the traffic level reduction in the inland Empire area, mostly in the San Bernardino County and the Riverside County, were not as significant as those other pockets and places. And if I continue playing this video, you'll see that that story was pretty much same when we went to May and June. We still see some part of the Southern California area has a significant drop of traffic, whereas the inland Empire area has pretty much went back to the pre-COVID level of traffic. In the next slide, I'm showing the change in speed. So in this case, the purple and the lighter shades, the yellow and orange, represents the increase in traffic speed compared to the pre-COVID level. So sometimes around the last weeks of March, when the traffic reduction was significant, we see several pockets of yellow and oranges were showing in the coastal regions, which are the regularly congested spots. And those are turning into lighter colors. That means that there was a significant improvement in traffic speed in those areas. Whereas across the board, we can see improvement of traffic speed. Although in the inland Empire area, we did not see a significant increase in traffic speed as compared to the regularly congested spots. So to understand the environmental justice implication of the COVID shutdown, we compared the traffic level changes with our CES score that we got from our calendar screen data. So I want to briefly explain the graph that we're showing on the right side. The x-axis represents the CES score from the calendar screen data. So the higher CES score means there are more vulnerable population in terms of socioeconomic and environmental exposure conditions, whereas the lower CES scores are where the less disadvantaged populations are situated. So as you can see in this plot here is that on y-axis, the percentage of change was variable in terms of the different areas and their CES scores. So the concentration of points are represented by the different colors. So when we see the lighter green shade in the middle of the screen, there are the most of the points aligned, and we can see a trend here that the lower CES score areas had a significant level of traffic flow change, and the higher CS areas, which are our more vulnerable population, that did not experience as much of the traffic flow reduction compared to the other areas. So to show the temporal progression of these environmental justice related issues, we looked into the progression of the total flow changes with CS score in the different months. And you can see at around April and May, we have fitted the data point observation with a regression line. So the maximum difference between 0 and the regression line, we can see are at the low CS score regions, the places where we believe the disadvantaged situation are not as pronounced, whereas the higher CS score regions where the more vulnerable population in terms of environmental exposure are living, for them, the traffic flow reduction is not as much compared to the low CS score regions. And we pretty much see the same trend following in the later months of COVID. Finally, we looked into the correlation of the CS score with the pollutant concentration. So we looked into the concentration of NOx and CO. And in this plot, you can see that in the x-axis, we have plotted CS score. On the y-axis, we have the percentage change in pollutant concentration for those different measurement locations compared to the pre-COVID level. And over here, we can see a concentration of points that are the near road sites on the top. So those are the locations where most of the traffic related pollutant concentration increased. Whereas we can also see that those points are also the high CS score regions. So we have the more environmental justice related implications for those areas. Whereas the non-near side locations are located on the left side of this plot, and they also they experienced reduction in air quality level, but did not experience at that level of the other near road side. So to think about the potential policy implication of the results that I have shown for the first few months of COVID is that we see that regionally, it is very highly variable. So some areas we see that they have experienced a significant amount of reduction in traffic flow level, whereas in the inland side, we did not see as much. And we think the reason for that is that for their access, the people living on those areas, they did not have access for remote work compared to the people on the other side. Most of the time, the nature of the job and the available technology to these people are limiting them to get proper access to the remote work. So what we think is that maybe if additional targeted incentives can be given to the business in the environmental justice impacted communities, it can help them to devise policies so that people are able to do telecommute more, and then the traffic level could be reduced for those areas also. And in terms of e-commerce, we see, and we saw that from Jill's presentation too, that the more consumption of online shopping items, that transfers to more warehousing activity. So we need innovative ways to manage additional trucking activities in the inland regions. So in conclusion, from this study, we see that from the Caltrans PEMS data, the traffic flow observed in the entire South Coast Air Basin, we saw that overall there was a reduction, but the traffic flow recovered at different times and scale for the different localized regions. And that causes some equity and environmental justice concern. And also we see that while the flow decreased, were generally more substantial for location with low CS score, the air pollution reduction were not linearly associated with the CS score. So in future, we try to find the underlying reason for the flow reduction. So why the different places had experienced traffic flow reduction differently. Is it because of more telecommuting, or is it because of increased e-commerce activities in some part of the areas? And I believe with that, we can have a significant policy-related understanding, so we can address some of these issues. Thank you so much.
Great, thank you, Shams. Very interesting talk. A lot of things to think about there. We're slightly over schedule, and so let's just do a quick 30-second question, and if you can answer quickly, that'd be great. But just like everything else, there are some written questions in the Q&A box, so if you can answer those by typing them in, that'd be great. But Shams, if you were to study this further or wanted to dive deeper, what do you need? I mean, do you need more data? What type of data? Can you just say a few words like that?
Yeah, so if you had seen those maps, you see there are some pockets in the map, which basically are the non-highway places. And we believe that interesting dynamics in terms of traffic flow reduction are happening on those non-highway places, specifically the downtown areas and arterial street areas. So it would be, we are on the process of getting some data from LA Metro on their arterial streets. So in future, I would try to take a deeper look into how the traffic dynamics has changed in the non-highway location and how that impacted the exposure to different traffic-related pollutants for people living around that area.
Great. Okay, thank you, Shams. And again, look at the questions in the Q of A. We have some very dignified people that have submitted questions. So we want to make sure we can get to that. Okay, we're slightly behind schedule, and what I'd like to do next is quickly introduce our Deputy Director at CSERT, Nicole Cleary. Nicole is obviously a very important person at CSERT in terms of our operations and running the place, as well as participating in a number of different projects. And she's done a lot of interesting work in air monitoring and other things. So Nicole, why don't you come on and tell us a little quickly about the prize and then about the Clean Air Pledge.
Matt, Nicole's Zoom just kicked her off. So,
oh.
I will just quickly discuss the Clean Air Pledge.
Sure.
So if everybody hasn't already, please make sure that you have visited the Clean Air Day website. So that's going to be cleanair.org. And from there, you can take the Clean Air Pledge. You can do that independently. There's a pledge for kids, and then you can also do it with the the company that you work for. So please, this is really important. This is why we're all here today. So please make sure you take that Clean Air Day pledge today. And so we are just going to go ahead and segue right into our, now that we're at time. So Matt, if you want to go ahead and introduce Barry, we can kick that off.
Sure. Okay. All right. Thank you, Jill. All right. So next we're going to switch gears and not have these, we had 4 great presentations. Now we want to make it a little bit more interactive with some panelists. And moderating our panel today is Dr. Barry Wallerstein, who came to us from the South Coast Air Quality Management District. As you probably know, Barry was the executive officer at South Coast AQMD from 1997 to 2016. And now he's very active with UCR, both within the School of Public Policy as a senior policy fellow, and also one of our research faculty at CSER. So Barry, with that, do you want to take it from here and introduce your panelists?
Sure. Good morning, everyone. It's a pleasure to be participating in this event. What we'd like to do is have the panelists actually do self-introductions, and I'd like to go in the following order. Vernon Hughes, Jennifer Lentz, Melissa London, and Andrea Polidori. So if you could each introduce yourself, then I will ask a question of each of the panelists.
Okay, hi, good afternoon, or good late morning, I should say, to everybody, and thanks UCR for including me as a panelist. I'm Vernon Hughes. I'm a CARB staff member. I'm the branch chief of the Community Assessment Branch in the Office of Community Air Protection, and currently acting director of the program. Been in the Office of Community Air Protection for, well, since the office was established to implement CARB's role in AB 617. Prior to that, I was involved in emissions inventory development, air quality modeling, and special studies at CARB. Been at CARB for 29 years now.
Okay, Jenny.
Hi there. Hopefully everybody can see my screen. I'm Dr. Jenny Lentz, and I am the program manager at the Coalition for Clean Air. Our organization does work in a number of areas ranging from legislation to advocating for clean technologies, organizing events like today's statewide Clean Air Day, which this webinar is a part of. Within CCA, I oversee a number of our CLEAR programs ranging from our air quality monitoring network to projects in disadvantaged communities, as well as school programs. So currently, we are working on trying to increase our local air quality monitoring by providing free air quality monitors to gap areas like Riverside and quite a bit of the Inland Empire. Now, while hosting a monitor does provide critically important local air quality information, we're finding that it doesn't necessarily improve the public's understanding of what air quality means, especially in terms of our own health. For example, prior to joining CCA, I bought my own purple air sensor, which is shown in the top left corner here, but I hardly ever remembered to go to Purple Air site to see what the sensor's reading were, and I certainly didn't know how different readings impacted my health. I'm excited to say that after joining CCA, I found out about IQAir's Air Visual app, which I personally consider to be one of the most important tools we can connect community members with. This app provides public hourly air quality data at the local level. It explains in a very easy to understand way how local conditions are impacting your health, what precautions you can take to reduce your exposure, and what you can do to improve your conditions. And what I'm really excited about is we've partnered with IQAir, and we're actively working to make sure every sensor in our network makes it into Air Visual as a public station, which means community members everywhere can get real-time alerts and information about their local air quality, regardless of whether or not they're able to host a sensor. And I'll post links to both of these in the chat window. Thank you.
Melissa?
Good morning. Yes, it's a pleasure to be here on California Clean Air Day. Thank you, UC Riverside and the Coalition for Clean Air for inviting myself and ACLIMA to participate. My name is Melissa London, Chief Scientist of ACLIMA. It says on this side. At ACLIMA, we've introduced a new way to measure and analyze hyperlocal air pollution and greenhouse gases. for entire regions using a fleet of roving sensors. Our vehicles are equipped with our own internet-connected sensing devices, and we measure block by block, day and night, weekends and weekdays, to get a high-resolution picture of street-level air pollution. Our research has shown that these pollutants, these pollution levels can vary consistently from one block to the next. The parameters we measure include PM2.5, ozone, black carbon, nitrogen dioxide, nitrogen monoxide, carbon monoxide, carbon dioxide, methane, and ethane. We are currently mapping across California as well as in New York and Mexico, including all 9 counties within the Bay Area Air Quality Management District, and in major cities around the world with Google through their Street View fleet. We are headquartered in San Francisco with offices in Oregon and New York. We map hyperlocal air pollution to support planning and decision-making by governments, communities, and businesses to reduce emissions and their impacts on public health and our climate. Our cloud-based software generates insights for our subscribers using visualization tools and automated analytics. Last year, we also launched a free online app, which is currently being piloted by AB 617 communities in West Oakland, Richmond, San Pablo, and San Diego. The app allows members of the public to look up street level air pollution averages by address, any address that within the mapped area. Much of the research presented today illustrates promising applications for this more fine-grained local air quality data and is very relevant to emissions reductions work we're supporting as part of AB 617. Such as Dr. Ivey's use of personal mobile data to support understanding exposure disparities, misclassification, or Dr. Luo's case study on rerouting trucks to reduce pollutant exposure in neighborhoods by the airport. Like we have with measurements, if we map in an area, we have measurements on all those streets and all those locations. Our team of scientists welcome the opportunity to support and collaborate on peer-reviewed research, and I'm delighted to be here today to discuss how transportation affects air quality. Thank you.
Andrea, it's your turn.
Hi, good morning, everyone. My name is Andrea Polidori, and I am the Advanced Monitoring Technologies Manager at the South Coast AQMD in the Monitoring and Analysis Division. I've been at the South Coast AQMD for about 11 years now, in different capacities. At the moment, I oversee 4 different groups. And so we are very much interested in both the development and deployment of advanced technologies for monitoring air pollution, the different particle and gaseous pollutants in real time, including air toxics. One of my group, some of you might have heard of AQ-SPEC, which is the Air Quality Sensor Performance Evaluation Center, where we do testing, where we do test commercially the performance of commercially available low-cost sensors, both in the field and in the lab. To date, so in the past 6 years, we have evaluated about 100 air quality sensors, but we have also deployed a lot of PM sensors throughout Southern California within different EPA programs or other grants that we got from different organizations and institutions. One of my other groups is developing strategies for monitoring different type of pollutants within AB 617. There was, one of the maps that you've seen during one of the previous presentations was developed by my group. And we are also right in the middle of implementing another important rule, which is called the Rule 1180. Which essentially has to do with monitoring a defense line of the 7 major refineries in the basin, and also trying to assess the potential, the impact of potential emission from refineries in the surrounding communities. So again, happy to be here, and I look forward to this discussion.
Thank you all very much. I'd like to now ask each of the panelists a question, and we'll be asking some different questions during this round. And Vernon, I'd like to start with you again. And I'd like to ask you about the fact that we live in a world of quickly evolving technology and public policy. And could you fill the audience in a little bit more on how CARB is evolving its activities and programs to be more responsive and improved response to communities that you are serving?
Sure, yeah, thanks for the question, Barry. Yes, it's certainly the program that I'm involved in now, it's really centered around AB 617. AB 617 was passed by the legislature, just not sure how much the audience may know about the program, recognizing that there are heavily burdened communities, communities that are facing exposure burdens that are much greater than the average burden across the state. So the program was established really to help address those challenges. So it's really a community scale, a community focused program, and that's one of CARB's areas of participation. We were directed through the legislation to establish guidelines for the program, and then the CARB board selects communities. Every year they consider additional communities to add to the program. So there's a number of communities, as it has already been mentioned. San Bernardino, Muscoy is in the Inland Empire. So certainly participation in that program, inclusion of just the topic of environmental justice. We do have an environmental justice group at CARB. So on that end, it's recognition of local scale pollution, integration of environmental justice, participation in the AB 617 program. Other elements of AB 617 are maintaining a database that essentially will bring in the data that are collected under AB 617. There's 13 communities now in the program. So such as the San Bernardino Muscoy community, for which the South Coast and Andrea's group is collecting data. That data will be uploaded into a statewide database that has these data in it. Also, just under the program, the 617 program, creation of community steering committees. So engagement, and that's something that the districts do as they're implementing the program in individual communities, is engagement of the communities through a steering committee process. Just another way of really listening to the communities, getting their experience on the ground of air quality effects. And then I mentioned online tools like the air quality, it's called AQView. That will be a system that comes up and will be a portal to display these data. There's also a technology clearinghouse we're looking at for control technologies that can be used. That's where I'll stop there. I've talked a little bit, try to keep it to a couple minutes.
Great, thank you. Jenny, could you now for the audience build upon your opening statement and talk about how communities are evolving their activities to build their technical and policy capacity to promote environmental equity?
Absolutely. We have a number of projects going on right now, funded through ARB's AB 617 program. And we're working locally with environmental justice organizations to really get a better understanding of what their challenges of their communities are, what their impacts are, and what they're going through. And as part of that, we're working to do things like truck count studies, air quality monitoring in the communities, lots of health outreach, health surveys to better understand what their baseline health is in these areas. One of the things we're finding in terms of technology is the communities that really are impacted the most and need the most resources, and especially things like air quality monitoring, are also some of the hardest communities to get that into. For example, we had one community where we were trying to deploy our Purple Air quality monitoring sensors there, and the community members actively wanted them, but a Purple Air sensor requires access to an outdoor outlet and Wi-Fi, which in most of these communities, very few people have any power to get an outdoor outlet at their location. And we're finding increasingly that most of these communities don't have Wi-Fi because they also don't have things like smartphones or even computers at their homes, which makes it hard for us to really distribute things like low-cost air quality sensors. But especially with COVID, it's making it even harder for us really to do the outreach with these communities. Prior to COVID, there was really active community outreach because everybody would go to one local place where they could pull up a slideshow and everybody could be in one room. We can't do that with COVID. We have things like Zoom. And even when you have a paid Zoom account so that people without a computer can call in, they can't see any of the visuals. So they aren't able to get the full experience and real engagement that they had prior to COVID. So even with the best intentions, we're running into these barriers that are really unfortunate because these are the communities that we really actively need to be helping the most. So we're working on ways to try and get around those.
Melissa, I'd like you to answer the same question and concentrate on this concept of building technical and policy capacity within the community to promote environmental equity.
Muting. We've learned quite a bit in working with the community members who are leading, emissions reduction plans as part of AB 617, particularly up here in the Bay Area and Richmond and West Oakland, and down in San Diego and the Portside community there. We've worked with, what we found is really helpful is really deep engagement with some of the advocacy groups in those areas, such as Mothers Out Front in San Diego, or the West Oakland Environmental Indicators Project up here, as well as working with the local air quality regulatory groups, such as the Bay Area Air Quality Management District here, to really not just to provide the data that we get from our hyperlocal mapping, but then also go to meetings, go to the community meetings, show the data, talk with the community about what the data is, how to even use it, like a lot of active outreach in that way, which has actually been also hampered a bit by COVID, but we found some pretty good success using Zoom, since ours is an online web-based application. And then also, as part of that, working with and getting information from the groups to understand how to better improve sort of the communication of air quality data in general. So a lot of really good feedback from the community that we actively take in as part of our, as a technology company, as part of our sort of development of our, our tools to sort of talk about the air quality. Like, how do we include the sorts of things that Dr. Lentz was talking about in terms of education, and what you can do is not just like, what is this measurement, then what can you do about it? Here's some places you might reach out to. Here's some activities that are going on in your community. It's really, I don't know, I've really enjoyed the really directly, really directly working with the communities. We also, because we have a fleet, we work hard to hire drivers from the communities we're actually mapping in. Our drivers are employees, and we found them to also be really good advocates. Not only that they know the situation on the ground, but they've also been really great in like working with other residents. It's their community, and some of them have actually become employees, become employees that help run programs within ACLIMA. So sort of trying to do in a way some capacity building in that sense. So capacity building from an employment point of view, but also capacity building from just a lot of deep engagement on communication and understanding what these communities need to see in our data and other data.
So I'd like to turn to Andrea now, and I'd like to switch gears a little bit. So we all know that COVID-19 has been having a tremendous impact. We've also seen tremendous impacts from forest fires this year, significantly impacting public health and the economy. So could you offer us some perspective as to what has been the overall impact on achieving clean air in the Inland Empire and potentially elsewhere in California?
Sure. So, I think that when it comes to COVID-19, and, we have seen from even, the presentation before that, initially I've seen that the initial reactions from some of the public and some of even the regulatory agencies when taking a look at some of the air quality data immediately after, COVID-19, there was quite maybe even a misunderstanding about the impact that it had on air quality. I think that, even some of the preliminary data analysis that we have conducted at the South Coast, but also talking to our colleagues at other agencies, it was clear that, the situation was a little more complicated than what, initially, thought. And, specifically, there were several factors that maybe, masked the real impact of COVID, or rather the real impact that air pollution still was having on the overall air quality, not just in the Inland Empire, but also on the South Coast Air Basin as a whole. And so, just to mention a few factors, the precipitation was one big factor that, very few agencies at the beginning took into account in order to really evaluate the real impact of, COVID-19 on overall air quality. Transportation was another, big, factor that, contributed to increasing air quality in certain area of the basin, including the Inland Empire, rather than, let's say, more kind of in downtown Los Angeles area. So all in all, when we put all of these elements together, it's quite clear, to me and to others that, despite of COVID, the air quality problem is still very much present in the Inland Empire, in the area, and that, although we will learn a lot about, how to mitigate air quality with, better policy, better regulation, better, management of traffic conditions in different areas. The problem is very much alive despite of, COVID, and despite of, some of, this type of episodic occurrences. And also, as highlighted during some of the, couple of weeks ago with the very high ozone day, especially because of the high temperature, one might say also because of the, increased impact of climate change. So, it seems that, kind of to conclude my, assessment and my answer to this question, I think that it's very clear that the air quality problem is very complex. And so I think collaborating with the both, air quality agencies, universities, putting a panel like this together where multiple, aspects of the air quality problem are analyzed and discussed is extremely important. And so I think, again, with COVID, we will have yet another opportunity to understand another aspect of air quality that we didn't know before.
Okay, very good. I'd like to remind the audience that they could go ahead and ask questions because we're now moving towards that phase of the panel. But before we do that, Vernon, could you just briefly talk about the same topic that Andrea just spoke to, but from the perspective of the State Air Resources Board?
Yeah, just on the impact of COVID and fires and such. Certainly, yeah, the fires are having a major impact on PM and the state. And then the COVID impact, a great presentation by Shams on the impact on VMT, travel patterns, et cetera. So that's something certainly that CARB is looking at as well. And it's interesting on the impact on chemistry. Certainly as motor vehicle emissions were reduced so extremely, and then likely there are, it was mentioned a little bit earlier too, the impacts of meteorology. It's a complex problem, as Andrea mentioned. Air quality is very complex and requires certainly interagency collaborations and work like this to really, like this group, to talk through findings and share findings. So yeah, on COVID, CARB we are looking at that. Findings we don't have yet, but it is certainly the traffic changes that have made a marked impact. And likewise, the fires, it's an active it's an active challenge in looking at the impact of fires, PM levels, and throughout the state.
Okay, I'm going to change the plan we had for the panel a little bit. I think I'd like to move at this point to ask each of the panelists, what is the most important message you would like the viewing public to remember from today's Clean Air Day conference? And let's start with Melissa.
Of course, yeah. Speaking as a technology company, the climate tech industry is rapidly growing, and there are lots of opportunities in both the public and private sector for people from all fields. We have a wide variety of people that work in our application, in our organization, from software developers to sensor technicians and meteorologists to marketers. California has really pioneered cleaner air policies, interventions, and innovations for decades. In this coming decade, we really need to rise together to meet this accelerating climate crisis like never before. Whether you're a student or a seasoned professional, I hope you consider, joining some of the organizations in the webinar, working for what I hope is a growing sector of sort of climate tech industry, really working to try to help solve these problems, and consider making climate action your day job, basically. If you're already working to improve public health and drive climate action, like my fellow panelists, I want to express gratitude for everyone really working in this very important space.
Jenny, would you like to comment as well, please?
Sure. As my high school history teacher would say, I believe knowledge is power. So I think one of the most important takeaways from today would be that it starts with really getting everyone to understand what their local air quality is, how it impacts them, and what they can do to protect themselves. This leads to advocacy, because once you really understand what's happening in your own life and how it's impacting you, and even how you can protect yourself and reduce it, that's, I think, the best way of really getting a movement of change. And that's one of the reasons I really love the Air Visual app, is it makes this data accessible, understandable, depending on what language your phone is in. It's multilingual, and it really is a really great tool to get this data to people so that we can start really making this publicly available and going beyond just publishing in journals, but getting the community aware and excited about it, or upset about it.
Andrea, your comment regarding the most important message you would like to conclude with.
Sure. So I would say that with the development of new air monitoring technology, community members, citizen scientists in general can now contribute to collecting air quality data in their neighborhood. For those of you that are familiar with AirNow, which is one of the more prominent website where you can get air quality information, pretty much in every part of the United States. AirNow is now starting to incorporate information about deriving from low-cost sensors, in their, in showing basically air quality conditions nationwide. So there are multiple resources that are available on the UCR website, South Coast, AQMD, AQSpec, CARB websites, to learn more about air pollution problems and how one can become part of the solution. Therefore, I highly encourage everyone to get more involved in understanding issues that are related to air pollution in their communities. Also, to take advantage of available resources, get in touch with local academic institutions and air quality agencies, and especially to take action.
Vernon, your turn.
All right. Yeah, thanks. Yeah, clearly, just based upon the presentations that were given, the panel makeup, this is it's a multidisciplinary challenge. Certainly on the science end, on the air quality end, but also the value that we as air quality professionals gain by engaging communities directly, like with the AB 617 program, is listening to and hearing from communities and how they're impacted. So our engagement to the communities is very important. Something I think that has been reflected here, as well as just participation of communities. Clearly, ingrained in most of the presentations were challenges that have been brought about through, say, land use decisions. So how we as public agencies engage and collaborate with land use agencies, show these kind of data, the impacts of land use decisions on air quality, and really work collaboratively with communities, land use agencies, and other organizations to influence change is critically important.
I'd like to answer this question as well. And I think it's in two parts. We frequently hear about the importance as individuals as to the choices we make as consumers and how we conduct our daily lives, and can do that in a way that is much more protective of the environment. And as the pollution control programs have evolved, the individual decisions made by consumers have become increasingly important. But the other part that I'd like to share with you is in my 38 years of experience working on public policy, I, on numerous occasions, was in a hearing, public hearing, to decide on public policy. And I think many people would be surprised how important a single witness can be who has taken the time to come and testify about how the air pollution or the proposed policy might impact their lives. And I've watched many a public hearing change because that individual decided to get involved and to participate. So on Clean Air Day, I'd like to just really encourage everyone to participate. You can make a difference. You don't have to be an expert in air pollution to do that. Your involvement is very important to good public policy and meeting our environmental goals. And with that, I'd like to, I guess, turn it over to Nicole.
Thank you so much, Barry.
Yeah, go ahead, Nicole.
Okay, no problem. So on that note, I think Barry left at a perfect segue to what I'm going to talk about, and that is how you guys can get involved. And you'll see a poll question there, and I guess it's asking us, what will you do as an individual to improve air quality? So this is, like Barry mentioned, one of the small personal choices that you guys can take. And so we'll see those poll answers in a second. In the meantime, I want to just share my screen for a moment and show you all about the raffle prize that we'll be giving away. It's a Smart Citizen Kit. It's an air quality monitor, and it includes air temperature, noise, ambient light, and particulate matter measurements. And it's a sensor that you build and can use. And so hopefully one lucky winner will be receiving that. I also want to take a minute to talk about, in your agenda that was linked in the chat room, if you scroll down past all of the agenda materials, you'll see resources for learning about air quality in the Inland Empire. And this has a lot of links that the presenters today talked about. For example, under Air Pollution Live Maps, we have the AQ Air app. This is, Dr. Lentz talked about this. We also have the Fire and Smoke map, and I believe Andrea talked about this one. I'll show you right here. So if you click on that, you can go to the fire smoke map, and you can see all of these sensors where people are, and these are low-cost sensors. So if you get an IQ Air or a Purple Air sensor, you can actually upload and have your data be on this map as well. So you could see the green shows, you know, good air pollution, where the yellow is somewhat unhealthy, and you can look more about what kind of maps is there. So this is a great resource for people. There's also information about the air quality basics and links there to some of CARB's stuff. And then in a moment, I'll be turning it over to Michelle, and she'll talk more about UCR's Community AIR program, where we're involving community members to get involved. And so we've partnered with various faculty and staff at UCR to roll out some community AIR projects with the community and also with high schools. And so you can learn more about those programs here if you would like to get involved as well. And so with that, I wanted to, oh, here's the results. And so I see it's very varied. But I love that 72% of you guys are taking the pledge. Let's make it 100. But that's great. So real quickly, I want to now introduce one of my colleagues, Michelle Burroughs. She has her master's degree in public health, and she's the deputy director for UC Riverside School of Medicine's Center for Healthy Communities. She leads the CHC in promoting community-based population health research. The mission of CHC is focused on remedying social injustices and inequalities that contribute to poor health, the inclusion of excluded voices, and systemic change to improve the health of individuals in the Inland Empire. Michelle, take it away.
Thank you, Nicole. I'm so happy to be a part of Clean Air Day in this webinar. You all mentioned something very, very important, the importance of getting our community members involved and getting them mobilized and into action mode so that we can all work collaboratively together to make sure that we're able to increase and improve our air quality in Southern California. So the Center for Healthy Communities and CSERT have been great partners, and we've developed a engagement resource collaborative. And the collaborative realized that, we can't just talk amongst ourselves on campus. We're doing a lot of great work. You all are doing a lot of great work as researchers around this topic area, but we need to engage, once again, the community. So we decided to involve and establish a community advisory board. Our community advisory board is put together to consist of representatives from the community, the general public, as well as some of our schools, our parents, just our general public agencies. And the purpose is to increase community awareness, to educate them on the issues of poor air quality and all the factors and variables that go into it, as well as to coordinate activities that we can do to engage the community so that they are, like I said, called into action. One of the exciting things that I'm wanting to share with you guys today, and I'll be sharing it, we'll be blasting it through our social media platform, is an opportunity for our community members to get involved. We've established a short film contest, and the contest, I will share the guidelines. Hopefully you all can see the screen. So the short film contest, we decided to put together because we wanted to, once again, engage the community and have them be a part of it. They understand that there's poor air quality in Southern California, but they really don't know what can we do about it and why should we be actively engaged in this. So we've developed this short film contest, and I will just kind of scroll down to the bottom of it so you can see our main purpose. Like I said, for engaging the community, we wanted to ensure that our community members understood that they can make a positive change in the community as it relates to air quality. We want them to understand that they can make an impact, that the film will be an opportunity for them to engage and to show how air quality is impacting them individually. One of the researchers on here mentioned that, providing being at an opportunity to some of our community members having the opportunity to report out at legislative boards and at our community councils or our local governmental councils. their voices can make an impact. Their ability to be able to share their stories and talk about, you know, how poor air quality has impacted their daily lives or impacted their, you know, their health and their well-being for their families is very important. So we wanted to, once again, use the arts to be able to show and how our community can express the impact of poor air quality on their lives. The guidelines for the short film are to, of course, submit it to our website, chc@medschool.ucr.edu. The short films can be submitted by individuals or student organizations. We ask that the films be at a minimum 8 minutes long, and we'll be using the judging criteria. We want to see that the short film shows the adverse effects on air quality in the IE. We want to show that it reflects the reality of the situation, pictures and showing people with their dignity, equality, support, and integrity. We want to make sure that these short films present a unique perspective of the issue, as well as present a practical and pragmatic solution. So I'm very excited for us to be able to launch this opportunity. Once again, we've talked to the community numerous times, and they oftentimes don't know really how they can lend their voice. They don't feel like their voice matters. And I think that this is a fun, like I said, unique way in order for us to get the community involved. And, you know, there's a little monetary gift that will go along with that. So they will have an opportunity to, if they get the first place prize, get $300, second place $150, third place $50, and then even more so being able to share and showcase their films on our web pages. So I'd like to also have Tilak, who is our fellow, our School of Medicine, one of our School of Medicine fellows. I'd like to have him go through a web page that we have started to develop, and we would love to get your input and be able to showcase the great work that you all are doing so that we can continue to, like I said, inform and educate our community members. So Tilak, would you like to share?
Yeah, thank you for that, Michelle. I'm gonna go ahead and share my screen. Can everyone see that? So piggybacking off of what Michelle was saying, we went ahead and established a community air quality project webpage under our current CHC webpage. So if you log on to the UCR Riverside School of Medicine CHC webpage, under our projects tab, the first tab you'll see is a community air quality project, and pretty much kind of building off of what everyone's been saying throughout this webinar, it's just a way that shows information and ways that air pollution impacts the community of Riverside. So we base this around the Riverside community, especially within the zip code 92507, and the residents living in there, and just giving them information on how air pollution impacts them, health concerns related to air pollution, and then this initiative that we're launching in conjunction with JW North High School, where we're partnering with the community members and the CAB board that Michelle was speaking of, and have them be a part of the solution on how to combat some of this air pollution in Riverside and California at large. So again, it just provides great information about how it impacts quality of life, health, why it's an important initiative in California, and then additional resources. So we're going to be constantly updating this webpage with exciting new opportunities for the community to get involved, learn about air pollution and ways they can help out to, again, reduce air pollution. Like right now, you have a link to the Clean Air Pledge that we've been mentioning. Also, there's a link to register for today's webinar. So this website is going to be constantly updated and gives a channel in a way for people in the community to be informed and also get involved with what we have going in this collaborative. So yeah. And I will provide a link to the website in the chat as well. And now I'll hand it back over to Nicole.
Great. So yeah, I encourage everybody to get involved, visit these websites, visit the resources that we've provided to find out more information. So also, if you have questions, please type them in the Q&A. We will try to answer these. If we don't get to them all, we will try to put the Q&A answers on the website, the Clean Air Day webinar website when we get back. So I think I'll turn it over to Matt to do the raffle.
Okay, great. Thank you, Nicole. So just, we were amazingly on time. I'm amazed we got through all that and quite a bit of great information. I wanted to thank all of our speakers for the presentations and all of our panelists. I think it was just chock full of a lot of great information, a lot of things to think about moving forward. So again, thank you, everyone. And I want to also encourage everyone to please always remember, check the CSERT website. We're always putting up news stories on our projects and different things that we're doing. There's a lot of good material there, and we're having a lot of fun looking into this type of stuff, and it's real important, I think, to our society. All right, without any further ado, we want to have the raffle prize announcement. And so, Jill, I think you're going to do that, right?
Yes. So thank you everybody for attending today. We had a really great turnout, and thank you to everybody, all the speakers and the panelists. So our winner today of the personal air monitor is going to be Julie Franco. So congratulations. I will be in contact. I should have your email. So you have won a free personal air monitor, Julie Franco. So.
Congratulations, Julie. All right, guys, that brings us to the end. I want to thank all of the participants and all the audience that joined us today. Like I say, keep tuned to what we're doing here at CSERT. There'll be more webinars like this in the future. So thanks again, and we'll see you. Have a good Clean Air Day. Bye.